Okay, we're now on page 4 of the review, and we're going to be writing these polynomials in vertex form by completing the square. And then identify the vertex. So in class, in person, if you were with me, we wrote down some steps. We said step 1 is going to be making space. So making space on this first one, we would write the x squared plus 4x, and then we leave space and then bump the plus 3 over. We're making space right here to complete the square by making a perfect square trinomial. So step 2 is the B work. Meaning if this is ax squared plus bx plus c, the 4 in the middle is your b value. So we go b over 2, or take half of b. So 4 over 2 is just 2 squared. So to complete this square, I'm going to be adding 4 because 2 squared is 4. Now, I can't just arbitrarily add a 4 to an equation without doing something else to balance it. So if I added 4 there and subtracted 4 off the back, see how plus 4 minus 4 would actually balance to 0? The reason I'm completing the square is so that I can get the perfect square factors in this next step. So do you see that the x squared plus 4x plus 4 could be rewritten as x plus 2 squared, perfect square factors, meaning what times what equals 4 and adds up to 4. It's 2 and 2. So the x plus 2 perfect square factors are what I just made, so this can be in vertex form. And then back off here to the right, plus 3 minus 4 is just minus 1. So here is my vertex form. Sometimes we write it in y equals, sometimes it says f of x equals. And then finally, my vertex comes from this number here and this number here. So if it's an x plus 2 in the parentheses, my vertex is a negative 2. And if there's a negative 1 constant off the back, my y value is a negative 1. So the vertex is known as hk for the horizontal shift to the x graph, and k is the vertical constant. And so negative 2, negative 1 would be my vertex. All right, let's go finish off those steps though at the top. Step 3 was where we factored the perfect square trinomial in order to make that vertex form. Step 4 is where we subtracted at the end to get it into vertex form. And then we found the vertex from that vertex form. And that was HK, where the H was this first part. Remember, we switched the sign, and the K was the second part. All right, let's go. Now that we've got the steps up at the top, let's go practice this a couple more times. Remember to pause the video, try some, and then check your answers. If you don't try any on your own, you're never going to be able to do this on your own on the test. So pause it now and try some. Okay, step 1, make space. Step 2, B work. Means I'm going to be adding 1 and subtracting 1. This makes the x plus 1 squared perfect, minus 6 off the back. And then what's my vertex? Negative 1, negative 6. How'd you do? Step 1, make space. Bump that 3 over. B work. Add 9 minus 9. This makes the x minus 3 squared perfect, minus 6 off the back. My vertex would be positive 3, negative 6. Step 1, make space. B work, adding 36 and subtracting 36 to balance. That makes the x plus 6 perfect. And off the back is going to be minus 29. That leaves me a vertex of negative 6, negative 29. Step 1, make space. B work. Negative 4 squared would give us 16. So I add 16 and minus 16. That's the x minus 4 perfect. And a minus 4 off the back for the 12 minus 16. That leaves me with a vertex of positive 4, negative 4. B work, 10 divided by 2 is 5. 5 squared is 25. So I'm going to be adding 25 and subtracting 25 off the back to balance. That makes the x minus 5 squared perfect. Minus 17 off to the back. My vertex is going to be positive 5, negative 17. By the way, we crossed out letter I in class so that H, we could have more space to work on it, and G is going to need a little bit of extra work. What's different about G and H is that they've got these coefficients in front greater than 1. So we're going to have to divide out to just complete one square at a time. So step 1, dividing out, is going to leave me x squared plus 3x. Oh, I don't want to do x squared plus 3x plus 2. We are not going to do this one in vertex form because, well, I will. It's just we won't have one like this on the final, so don't worry about any one that's complex. But what's so weird about it, and by the way, hang on. We are just going to move. So x squared plus 3x, notice that when I divide it out of 2, this is going to leave me a 3 in the middle, and that is not ideal for a complete the square, because when I go do the B work, 3 divided by 2 is, it's a fraction, it makes 9/4. So when I do this, it's going to be the x squared we're adding 9/4 and subtracting 9/4 2 times. Ooh, right? So anyways, this makes the x plus 3 halves perfect. And then over here, let's simplify this out a little bit. 4, and then the 4 and the 2 cross out, leaving me minus 9 halves. 9 halves is 4.5. Oops, get rid of that parentheses. And so that's going to leave me negative a half or negative 0.5, however you want to write it. Because 4 is 8 halves, right? And so what's my vertex? My vertex is negative 3 halves, negative 1 half. Are we going to have to complete the square on an odd B? No, you're going to not have to do this. But can it be done? Sure, I just did it. But you will not have to do this on your final exam, FYI. Okay, so pause the video, go try this one and the next one, and let's see how you did. This time we're going to be dividing out of 3 of the first 2 terms. So we're left with 8x squared minus 8x, and then go ahead and bump that one over. Go do the B work. Negative 8 divided by 2 is negative 4 squared, which is 16. And so we're going to add 16 and subtract 16 3 times. So there's a 3 here, so it's got to be subtracting 16 3 times. Okay, let's break this up into the perfect square trinomial. It becomes the x minus 4 squared perfect, and this is going to be plus 1 minus 48. and that becomes a negative 47. So my vertex is 4 comma negative 47, and then don't worry about doing letter I. Okay, for this next one, greatest common factor. You were used to me teaching you how to stretch out this like 3 times x times x times x times y times y times y times y. And then the next one is 3 times x times y times y. Do you see how I'm stretching out these terms? And then we look for what's in common. So if you want to go back to your greatest common factor notes from first semester or watch some videos on how to do that, feel free. But let's go ahead and just check your answers. In this first one, a 3 can divide out of everything, and 1x. Notice that there's not a y in everything, there's not a z in everything, so this is done. Your GCF is just 3x. On the next one, 15, 3, and 10, no number can divide out of any of those, so there's no number in front. There's an A here, there's an A here, there's an A here. What is the most A's I can have in common? I notice that it's just 1A. There's a B here, there's a B here, there's not a B. There's a C here, there's not a C. So A is literally the only thing in common between all three terms. The next one, a 4 can come out. See how a 4 can go into 24, 4, and 12? S's are in everything. What's the most S's I can have in common? Just 1. T is in everything. What's the most T's I can have in common? Just 1. 4ST is your greatest common factor. On the next one, for 36, 45, and 24, I'm seeing that a 3 can go in. I'm not seeing anything bigger. So 3 goes into 36, 3 goes into 45, 3 goes into 24. How about M's? Yeah, there's at least one M in common. How about N's? Yep, there's at least one N in common. On this next one, there's no number that goes into everything. There are some X's. X to the 6th looks like the most X's that we can have in common. Y to the 4th looks like the most Y's I can have in common. And Z to the 3rd. So my greatest common factor is X to the 6th, Y to the 4th, Z to the 3rd. Finally, on the last one, 24, 48, and 32. Do you see how an 8 divides into everything there? And then A to the 5th seems to be the biggest number of A's, smallest number of A's that we can have in common. B's, we can have B to the 4th from this guy up here, and then C's, we can have C to the 8th in common. So 8, A to the 5th, B to the 4th, C to the 8th is my greatest common factor. For section 4, we didn't have to do that section. I did put the answers in case anyone tried it, but it's just taking the square root. And then check this out. The square root of anything squared is just that anything. Square root of anything squared is just that anything. So keep that little trick in mind. Sometimes there's way less work than you need on square rooting. Okay, how'd you do on that page?